Hi, Assalamualaikum and good day to all students. For this video, we are going to cover for the tutorial of chapter 7 whereby it involves with fluid mechanics or fluid flow. Okay, so you have 5 questions for this particular tutorial and let's begin. Alright, so now for question number 1, it has been given to you milk at 303 Kelvin flows at a velocity of 29.5 centimeter per second. So what you need to do is, the first thing is that you need to list out all the values given in the problem statement. So it has been given to you that the velocity is 29.5 centimeter per second. So what you need to do is, this particular centimeter you need to convert to meter, alright, in order for you to get the velocity value as meter per second, not centimeter. Okay, and the internal diameter is given to you as 5.35 centimeter. So again, you need to change that particular diameter to meter. The density and viscosity of the milk are given. Okay, show that the flow is turbulent. Okay, when you are given with this kind of question, show that the flow is turbulent, what you need to do is you need to calculate for the value of Reynolds number. Okay, so in order for you to calculate the value of Reynolds number, you need to make sure that all the values are consistent. All the units must be consistent unit. Okay, and it needs to be in SI unit. So that's why your diameter, okay, the diameter has been given as 5.35 centimeter, and this particular centimeter you need to convert to meter as well. So after you have convert the value for the velocity as well as for the diameter, then you can calculate the value for Reynolds number, dV rho over mu. Okay, so the value is 8,855.74. So how do you want to show that this particular flow is turbulent flow or laminar flow? Is by proving that the value of Reynolds number is greater than 4,000. So now, after you have calculated the Reynolds number, the value is 8,000 plus. So you need to put some conclusion whereby the flow is turbulent because the Reynolds number is greater than 4,000. Okay, and then for question 1b, what will be the change that you need to do in order to obtain laminar flow? So basically, when we want to change whether the flow should be turbulent or laminar flow, you need to change in terms of the velocity of the fluid, in terms of the velocity, or probably in terms of the diameter. Okay, so for now, it is easier for you to change the velocity because the diameter of the tubing has been given to you. So just change in terms of the velocity. So for laminar flow, the Reynolds number should be less than 2100. So just by using the same equation, Reynolds equals to dV rho over mu. Okay, use this particular equation over here. Alright, but then leave this particular V as unknown. Okay, so what you need to do at that, in order for you to convert from turbulent flow to become to laminar flow, from turbulent to become laminar flow, so you need to slow down the flow whereby after you have calculated the value for V has reduced to become 0.06995 meter per second, or when you convert to centimeter, it is only 6.995 centimeter per second, whereby it is a very greatly reduced compared to the initial velocity, which is 29.5 centimeter. Okay, so this one solved for the first question. Now let's move on for second question. Okay, at what velocity does air and water flow? The water flow will convert from laminar to transitional in a 5 centimeter diameter pipe at 20 degrees Celsius. So it has been given to you the physical properties of the water and air. The density of water at 20 degrees Celsius is 998.2 kilogram per meter cubic, whereby the viscosity of water at 20 degrees Celsius is 993.414 times by 10 to the power of negative 6. Okay, whereby for the air, the density is given to you as a 1.164, whereby the viscosity of air is 18.24 times by 10 to the power of -6. Alright, so let's calculate. Alright, so what you are going to do is you need to calculate for the velocity. Okay, this one just simply plug in the values, whereby you have been given with the diameter. The velocity is the unknown. This one is what you need to calculate. The rho has been given, the mu has been given. Okay, so in order for you to convert from laminar to transitional, you need to get the value for the range of the Reynolds number. So what will be the value for Reynolds that you need to use? You need to use the value of 2100, because this particular value of 2100 is overlapping between the laminar flow as well as the transitional flow. Okay, so calculate the value for V, then for the water. Okay, for the water you will get the value for V is 0.042 meter per second, whereby for the air, by applying the same equation, the velocity of air is 0.658 meter per second. Alright, now let's move on to the following question. Question number 3. Water is flowing at 40 liter per minute. Okay, 40 liter per minute. This one, basically we are talking about volumetric flow rate. Okay, this one what we are referring as a volume, sorry, is a volumetric flow rate. Okay, 40 liter per minute in a 2 cm diameter pipe, 10 meter long at 20 degrees Celsius. Okay, so again, the water, for this particular problem statement, the temperature of water is at 20 degrees Celsius. So in order for you to get the physical properties in terms of the rho as well as the mu of the water, you need to refer back to the question number 2. Okay, refer to question number 2. Okay, because in question number 2 has been given to you the value for the rho as well as the mu at 20 degrees Celsius. Alright. So calculate whether the flow is turbulent or streamline, and it is been given to you that 1 meter cubic is equivalent to 1000 liter. So what you need to do is this particular volumetric flow rate, you need to convert from 40 liter per minute to become meter cubic per second. Alright, so after you have calculated, you should be able to get the flow rate of the water is 6.67 times by 10 to the power of -4. Alright, and then afterwards, the following step, you need to calculate for the area, because we are going to cancel out the unit in order for you to calculate for the Reynolds number. Right, so for the cross-sectional area, pi over 4 times by d square, so you should be able to get this particular value. Okay, basically it is a 3.14 times by 10 to the power of -4 meter square. Alright, and then so the first one you need to convert flow rate, volumetric flow rate. Then the second step, you need to calculate for the cross-sectional area. The third step is you need to calculate for the velocity of flow, because this particular volumetric flow rate, this one is not velocity. Okay, this particular 40 liter per minute is not velocity. Velocity is, the unit should be given to you as meter per second. Alright, so what's happening is that this particular 6.67 times by 10 to the power of -4 you get from the volumetric flow rate, followed by this particular area. So in order for you to get the value for velocity, it is equivalent with the velocity volumetric flow rate divided by the area. Okay, this volumetric flow rate, basically it is being denoted by V with the dot, capital V with the dot on the top of the V. Okay, so V over A, volumetric flow rate over the area, then you will get the value of velocity of the flow, 2.12 times by 10 to the power of -4 meter per second. Alright, and then afterwards, the following step is calculation for the Reynolds number. Okay, whether you need to prove whether the flow is either turbulent or streamline. So calculate the Reynolds number. use the equation dV rho over mu. Then when you calculate the value of Reynolds number, it is 42,604. So of course this particular flow is turbulent because the Reynolds number is already greater than 4,000. Alright, now let's move on to question number 4. For question number 4, this one is the same step that you need to apply from your lecture notes as well. Okay, calculate the pressure drop of star fruit juice drink that flows with a velocity of 1.5 meter per second through 1.2 meter of horizontal sanitary stainless steel. Okay, that will be the L. Right, so the velocity has been given to you from this particular question number 4. Velocity is 1.5 meter per second. 1.5 meter per second. And then it has been given to you that the length of the tubing, okay, is 1.2 meter. Okay, so it is important for you to list out the values that has been given to you from the problem statement. And then the inner diameter, DI, this one I denote as DI, is 9 millimeter. Okay, 9 millimeter. So from DI, you can calculate for the RI. So divide by 2, 9 times 9 divided by 2, you should be able to get around 4.5. Okay, and then afterwards you can calculate the value. Okay, the density and viscosity of star fruit juice drink is been given to you. Calculate the energy loss due to the friction. Okay, so use the Moody diagram to solve this particular problem. So what you are going to do is involving with 5 steps. So the first step is you need to calculate for the value of Reynolds number. Okay, equals to dV rho over mu. Alright. The diameter value has been given to you, but of course, this particular unit, millimeter, you need to convert to meter. Okay, you do not need to calculate for the RI. Okay, dV rho over mu, V has been given to you, rho has been given to you, as well as mu has been given to you. However, you need to make sure that you insert the right value for each parameter. Okay, rho is density, mu is viscosity. Okay, so the value for Reynolds, you should be able to get around 38,812.5. It is also almost equivalent to 3.9 times by 10 to the power 4, but since we are going to refer to Moody diagram, it is difficult for you to use the diagram to get the value of from 3.9 times by 10 to the power 4. So what you need to do is you round it off to become 4 times by 10 to the power 4. Okay, so this one is number 1. Alright, and then the following step, whereby you need to get the value for relative roughness. This particular epsilon value, you are going to get it from the diagram, and you need to look for the material. Okay, so the material for this particular tubing is stainless steel. So the material of epsilon is 45.7 times by 10 to the power -6, followed by the diameter. Okay, this particular diameter, the value of diameter. So the epsilon over D is 0.005. So you need to get the intercept value between the Reynolds number as well as the epsilon over D. Then you will get the friction factor as 0.00825. Okay, this one is very precise. Alright, so afterwards, after you get the value of friction factor, then we move on to calculate for the delta P, the pressure drop, because the last step is going to be calculation of the energy loss due to the friction. So for pressure drop, use the correct equation again, whereby the equation is 2F rho V. This one is supposed to be V square. Okay, V square times by L divided by D. So you should be able to get as 11,385 kilogram per meter second square, or you can also express this particular value as 11,385 Pascal. Okay, actually they are the same unit. Okay, so after you have calculated the value for delta P, then the last step is for you to calculate for the energy loss due to the friction. By using the equation of delta P divided by rho, then you should be able to get the energy loss due to the friction is 4.95 joule. Okay, so this will be for question number 4. And then for question number 5 also, you are going to have the same step that you need to apply in order for you to solve the problem. Okay, now let's move on to question number 5. Calculate the pressure drop. Okay, this one, calculate the pressure drop, meaning that you just need to calculate for the delta P. It does not require for you to calculate for the energy loss due to the friction. So calculate the pressure drop through horizontal sanitary stainless steel tubing. Okay, the radius is been given to you as 9 millimeter. Okay, inner radius Ri is given to you as 9 millimeter. Okay, this one is to trick you. So what you need to do is you need to times by 2. So di you need to times by 2 in order for you to get the inner diameter, because we are going to use diameter, we are not going to use Ri, we are not going to use radius for this particular problem statement. Okay, and then this particular millimeter you need to convert to become meter. Okay, so the length is 1.2 meter for an apple juice drink that flows with a velocity that has been given to you. Density, viscosity also has been given to you. So use the Moody diagram to solve the problem. So the same step apply. So the first thing first, what you need to do is calculation of Reynolds number, dV rho over mu. Okay, this particular D, remember, we have calculated whereby the value for D is supposed to be 18 millimeter, but then you need to convert to meter. Okay, the velocity has been given to you as well. Okay, 3.13 times by the rho divided by the mu. Okay, you will be able to get the value as 75,858.75. And this particular value, when you simplify, it becomes 7.6 times by 10 to the power 4. Okay, and then since this particular 7.6, it is can be rounded off to become 8. So this one is for you, this particular value is for you to use in order for you to get the intercept value for the value of friction factor. Okay, and then followed by the second step, relative roughness, the same thing. Alright, so this one is supposed to be 0.018, not 0.09. Okay, this particular value you need to make sure that it is being corrected to become 0.018. Okay, so the value after you have calculated, you will get around 0.0025, round it off to become 0.003 because this one is to ease you. Okay, I think you have learned during your high school, if let's say the number is already 5 and above, you can round it off to the nearest digit number. Okay, the same thing goes right like this one, 7.6 is already exceeding 0.5, so you can round it off to become 8. Okay, so for this one 0.025, when you round it off, it can become 0.03. However, if let's say your answer is 0.0024, you cannot round it off to become 0.03. That is wrong because this particular value, number 4, is not yet exceeding number 5. So this one, if you want to equalize, it will become 0.0020. You want to round it off, it should become 0.0020. Okay, so for now, you have the value for relative roughness, epsilon over D as 0.003, and your Reynolds number is 8 times by 10 to the power 4. Then find the intercept point between the Reynolds number and the relative roughness. So you will get the friction factor as 0.007. Okay, then you need to calculate for the delta P. Okay, for this particular problem statement, you just require to calculate for the delta P. You do not need to calculate for this particular energy loss due to the friction. Alright, so for the delta P, use the equation 2F rho V square L over D. Then you will be able to get the value of delta P as 10,058 kilogram per meter second square. Okay, so that's the end of this particular tutorial of chapter 7, and I hope you will try to do this exercise on your own. Try to practice how to use the Moody diagram and try to practice how to solve the problem statement given to you in your tutorial as well as in your lecture notes. Okay, so thank you for your time and cooperation. I'll see you in next video.